Imagine gazing into the vastness of the cosmos and suddenly sensing it staring right back at you. That's exactly what scientists experienced when the James Webb Space Telescope, the most powerful instrument of its kind ever sent into orbit, detected something completely unforeseen. This wasn't just another distant galaxy or a stunning nebula to admire. What appeared were signals, patterns, and irregularities that broke every rule we thought we understood about the universe. At first, it all seemed random, but the more researchers examined the data, the more it began to feel intentional, structured, and, some would even argue, intelligent. For decades, it was widely believed that the universe was indifferent to us, a cold, boundless void ruled by physics and chance. But what if we've been mistaken all this time? What if, buried in the silence of deep space, there are messages waiting to be uncovered, messages never meant to be intercepted? It all began with a strange anomaly, not light years away, but relatively close to Earth. Webb was focused on Neptune, one of the frozen gas giants at the edge of our solar system, a planet so remote and cold it often feels suspended in both time and space. Yet Webb detected something that appended decades of established knowledge. Compared to data gathered from Voyager 2's 1989 flyby and recent ground-based observations, Neptune's upper atmosphere had cooled dramatically, not over thousands of years, but within a few decades. The readings were undeniable. Sections of the atmosphere had dropped nearly 10 degrees Celsius, with no obvious explanation. Solar activity didn't account for it. Internal planetary fluctuations didn't either. What's more unsettling, Webb detected subtle disturbances in Neptune's magnetosphere, gentle pulses, almost like the heartbeat of something we never realized was alive. Could an outside force be acting upon the planet? A gravitational anomaly, a change in dark matter density, or perhaps something even more inexplicable, something influencing planetary systems across unfathomable distances? The anomaly was only the first step. Behind it lay something far more enigmatic than ice, a mystery waiting to be unraveled. Well, the Neptune data raised serious questions. What Webb discovered in the TRAPPIST-1 system compelled scientists to rethink the very foundation of exoplanetary research. Just 39 light years away, TRAPPIST-1 is already notable for having 7 rocky planets, 3 of which reside in the system's habitable zone. But Webb didn't just confirm that these worlds could support life. It uncovered something far more profound. Infrared spectroscopy revealed the distinct chemical signatures of water vapor in the atmospheres of at least 2 of the planets TRAPPIST-1d and TRAPPIST-1e. And these weren't mere traces. The data suggested dense, moisture-rich atmospheres, potentially complete with cloud systems similar to Earth's. Alongside temperature data and orbital resonance observations, the most plausible scenario emerged: global oceans, deep, stable, and ancient. Even more surprising was the presence of ozone-like molecules, chemical markers associated with biological activity on Earth. While not direct evidence of life, it's the closest scientists have ever come to identifying the ideal conditions for it. And here they appeared not just once, but twice in the same planetary system. Imagine a miniature solar system with multiple Earth-like planets circling in silence. Webb has now shown us they're not merely theoretical, they are real, dynamic, and possibly alive. Yet even that wasn't the telescope's furthest reach. In one of its deepest observational sweeps, Webb captured light from a galaxy named Jade's GSE 130, formed just 330 million years after the Big Bang, among the oldest ever seen. What puzzled scientists wasn't just the galaxy's age, but the strength of its Lyman alpha radiation, a wavelength typically absorbed by neutral hydrogen in the early universe. This light, however, passed through untouched, as if the hydrogen had already been ionized. This observation disrupts our understanding of the cosmic epoch of reionization, the era when light first began to pierce the primordial darkness. If this radiation was emitted at that point in time, something must have accelerated the process, something powerful, or perhaps something intentional. Was this simply a natural variation, or a sign of deliberate cosmic engineering, hinting at forces or intelligences at work in the universe's earliest moments? The implications are nothing short of staggering. We are no longer just asking what happened, we are beginning to wonder who, if anyone, made it happen. Next, Webb directed its instruments toward white dwarf systems, remnants of stars long since extinguished. Scientists expected only debris and silence. What they found instead challenged everything they knew. In the system WD 1856 plus 534, Webb detected a massive gas planet orbiting incredibly close to a dead star, something previously thought impossible. The star's transition into a white dwarf should have obliterated any nearby planets. Yet this one survived and seemed stable. Even more astonishing, traces of vaporized water and sulfur compounds were found in its upper atmosphere, suggesting that the planet's atmosphere is regenerating. Somehow, this world has adapted to survive the death of its sun. This finding disrupts the traditional model that ties habitability to active stars. Could there be life or even civilizations built around dying stars, evolving to thrive in fading light, powered by alternate energy sources? If planets can endure the death of their stars, then perhaps life can too. White dwarfs, long considered symbols of cosmic finality, might in fact be sanctuaries for resilience and survival, perhaps even intelligence. Closer to home, Webb turned its attention to the forgotten outer moons of Uranus and Neptune, long dismissed as frozen, lifeless rocks, but Webb's infrared sensors revealed something unexpected: heat signatures. Several small moons, including Hippocamp and Despina, displayed temperatures far exceeding expectations, indicating active geology or cryovolcanism beneath their icy shells. Even more intriguing, traces of complex carbon compounds were found possible, precursors to organic chemistry. This sparked immediate questions. How could these tiny, distant moons retain internal energy for billions of years? Some suggest radioactive decay or tidal heating, but those theories don't fully account for the apparent structure of the compounds observed. Another possibility emerges: external seeding. Could these moons be remnants of something ancient, their surfaces marked by purposeful chemical delivery? Then came one of Webb's most baffling findings from a galaxy long familiar to astronomers. Messier 82, also known as the Cigar Galaxy, is a known starburst region teeming with stellar activity. But Webb uncovered something deeper: an infrared pulse, repeating at precise intervals, emanating from the galaxy's core. This wasn't random noise or instrument error. The signal had mathematical regularity, structure, and timing. Well, some propose it could be a spinning neutron star or other energetic process. Nothing in other wavelengths supports this. The possibility lingers. What if this is the echo of a transmission, not intended for us, but intercepted by chance? Tabby star or KIC 8,462,852 had already drawn attention due to its irregular dimming, once speculated to be caused by alien megastructures. Webb took a closer look and, instead of dispelling the mystery, it deepened it. The telescope revealed that the dimming isn't caused by dust or debris. Instead, flat, opaque objects seem to pass in front of the star, inconsistent geometric patterns, possibly massive structures moving in synchronized orbits. The thermal data revealed a faint, constant infrared glow in the area, waste heat that doesn't match the star's natural output, as if something nearby was collecting energy and radiating the excess. The idea of a Dyson swarm, once science fiction, is now being seriously considered. Finally, Webb turned to AL 2744, known as the Pandora Cluster, a swirling mass of galaxies whose gravitational lensing allows us to glimpse the ancient universe. But this time, something unexpected happened. During long exposure observations, shadows moved across a background galaxy not once, but repeatedly. These weren't errors. These were real occultations. Something had blocked the light. But no visible object was responsible. These intrusions emitted no light and reflected none. They could only be seen by what they obscured. Based on their motion and consistency, researchers speculate they might be massive yet invisible, perhaps advanced constructs or structures designed to avoid detection. This isn't missing matter. It may be hidden technology operating within the rules of physics but exploiting them to remain unseen. What Webb is uncovering isn't just scientific detail, celestial beauty, or cosmic wonder. It's something deeper, a quiet, unsettling pattern clues scattered across the stars, each one testing the limits of our knowledge, whispering the same quiet question: what if the universe was never empty? What if we've been watched the whole time? From Neptune's cooling skies to rhythmic pulses in faraway galaxies, from Earth-like planets circling faint red stars to invisible shapes drifting across primordial light, Webb hasn't just opened our eyes. It has peeled back a layer of reality we didn't know existed, one we may not have been meant to see. And now that we have, there may be no going back. We may be standing at the threshold of a discovery that changes not only science, but what it means to be human, a truth that the universe is not just immense, it might be aware, watching, reacting, or even warning. But whatever comes next, this is only the beginning.